hope you're okay. Okay, we're going to start this evening and hopefully work through as many of the applied papers as possible. You'll have to excuse me, it's quite late. I hope I don't make any mistakes. I've written out all the solutions, so we should be okay. But let's see how we go. Right, so let's open the file. Here we go. Okay, so we've got question 1 there. So we've got a rough plane is inclined to a horizontal at an angle alpha where tan alpha is 3/4, a brick of mass P. So always draw yourself a diagram. It's so much easier. It's much nicer when they draw it for you, but they haven't in this case. So we've got a rough plane. It's inclined at alpha. We know that tan alpha equals 3/4. Tan is opposite over adjacent. So sine alpha is 3/5 and cos alpha is 4/5. Okay. A brick of mass P is placed on the plane. Okay, so here's my brick. And that's going to have a weight going down of mg. So as soon as I have a plane and a force, I draw my mg in, I draw my resultant force in, and then I resolve it. So remember, your mg has to be your hypotenuse. This alpha is always alpha here. Opposite is sine, adjacent is cos. Right. It's on the point of sliding down. So that means the friction is acting up. Now, you'll see in some places they use F or FR. You can do that, but I would always immediately write mu R. So you know that friction is mu R. You can write that in immediately without doing anything else. Okay, so now we've got a diagram. We should make everything easy. And essentially, all we're doing is we're resolving perpendicular and parallel. Now it's asking us to start with finding the normal reaction. So that means we're resolving perpendicular to the plane. It's kind of up equals down, but at the angle. So we can see that going upwards as such, we've got R. So we're like R equals, and the only other force going the other way is mg cos alpha. And we've already said cos alpha is 4/5. So we get 4/5 mg. So we've written in terms of m and g, the normal reaction. Now we're going to resolve, it's an equilibrium, it's not moving. So we're thinking F equals ma, A is 0. So going up the slope equals going down the slope. So we've got mu r, so this is where it comes into use doing this. So mu r equals mg sine alpha. Now we've already worked out what r is. So mu times by 4/5 mg equals mg, and we said sine alpha was 3/5. Now what's on both sides? mg, we can get rid of that, right? And we can multiply both sides by 5, and you've shown that mu equals 3/4. So that was nice and straightforward. It now tells you you're not required to do any further calculations. Now, this has become a little bit normal in some of the A-level exams where you've got to explain things, where your instinct is to do a calculation. So now they're saying brick P is now removed and Q is put on the plane. Okay, fine. And it's much heavier. So explain briefly why Q will remain at rest. Well, the friction will also increase by the same amount the mass increases, because if we think about it, friction is equal to mu r. R is dependent on the mass of whatever's on the mass of the brick. So therefore it will increase in proportion, so nothing changes. So your answer would be the friction will increase in the same proportion as the weight. So then it says block brick Q is modelled as a particle. Using the model, describe them. Okay, so it's now projected down. Sorry, I missed that bit. So it's going down the slope and describe the motion. So it's going down the slope at a speed, but there's still no acceleration. So it's going to move at a constant speed as no acceleration, let's say no resultant force. So there's no force pushing it down, force down the plane. So no acceleration. Okay, I hope that makes sense. Let's have a look. I'll leave that on there for a few seconds, or you can pause this if you need to write it down, but hopefully that makes sense. Let's have a look at the next question. Okay. So we've got a rough plane is inclined to the horizontal at an angle alpha, where tan alpha is 3/4. Can you see how all of these are starting to look a little bit familiar? A particle mass P is placed on the plane, and this one is projected up. The coefficient of friction is mu, and now it's telling you it's moving up the plane. So let's draw it and let's see how that's different, but most things will be the same as what we've just done. So we've got mg. We've got tan alpha equals 3/4, and then we've got sine alpha is 3/5, and cos alpha is 4/5. Right, we're also still going to have our r, I'm sure I've left enough space, and we do exactly the same as we did before. Down and across, that's also alpha, mg sine alpha, mg cos alpha. So it's always that, no matter what your slope looks like. Right, we know that it's projected up, so it's moving up the plane. So we draw an arrow with 2 arrows there to represent acceleration. It's decelerating, but it's still going up. So we do it going upwards, but we write minus 4/5 g. And that means friction's acting in the opposite direction to the movement. And we're going to get used to the habit of writing mu r. But you can write fr if, you know, in case your school teachers want you to write that. And we're going to find mu. So we're going to start with up equals down, because it's not jumping up, so there's no acceleration. So if we think of F equals ma perpendicular, we've just got r equals mg cos alpha. And we know cos alpha is 4/5, so r equals 4/5 mg. Okay, now we do F equals ma in the direction of acceleration. So going up the slope, there's no forces. All the forces are going down. So everything going down will be negative. So we've got minus mg sine alpha minus mu r equals m multiplied by the acceleration, which is minus 4/5 g. So everything is a negative. We can just make them all positives. Makes life a bit easier. And sine alpha is 3/5, so we get 3/5 mg plus mu, and we know that r is 4/5 mg, right? And that equals 4/5 mg, right? So mg's cancel everywhere. So 4/5 mu is going to be 4/5 minus 3/5, and which gives you 1/5. So then mu is equal to, times it by 5, divided by 4, 1/4. The particle comes to rest at a point A on the plane. Determine whether the particle will remain at A. So what we need to think about is it going to stay at A? Is the friction more than the force going downwards? So it gets to A, there's a force of the weight, so you've got mg sine alpha pushing it down the slope, and you've got friction, which is going to make it go it's going to stop it going down because it'll act in the opposite direction, or the weight is more than that. So let's have a look at what that comes out to be. So if we clear that, we've got mg sine alpha, which is our component of weight going down the slope, which gives us sine alpha was 3, okay, so we had 3/5 mg. So that's our weight component going down. So we'll say like going down the slope. And then we've got friction, which equals mu r. Now mu doesn't change, it's to do with the slope. So 1/4 times by 4/5 mg, which leaves you with 1/5 mg. So the weight going down is more than the friction stopping it. So your conclusion will be it will move down the slope as 3/5 mg is greater than 1/5 mg. Right, next question. A wooden crate of mass 20 kilograms is pulled in a straight line along a rough horizontal slope using a handle attached to a crate. They do like tan alpha is 3/4 here. It also just makes the calculations nicer. You almost don't need a calculator. So sine alpha is 3/5 and cos alpha is 4/5. And for anyone that's confused, that comes from a triangle, if you like, where tan is TOA, so opposite over adjacent. So you get a 3, 4, 5 triangle, and then you can come up with the other bits. So we've got a wooden crate of mass 20 kilograms. So we know we've got 20g going down. We've got a resultant force going up. It's a rough horizontal ground. The tension, the handle is inclined at an angle. So wherever we've got anything at an angle and we've got a straight slope, we want to resolve everything to that. So to go from this end of the vector up the vector, we've got to go along and we've got to go up. So this becomes 40 sine alpha, and this one becomes 40 cos alpha. Okay, the tension in the handle is 40. The coefficient of friction is 0.14. So coefficient is your mu. So if it's being pulled this way, then that means the friction is acting always in the opposite direction to where it's moving. So it's going to be moving that way. That's my acceleration. The friction is going to be acting in the opposite direction. So friction, which equals 0.14 R. So friction, which equals mu R. So we find the acceleration in the crate. So before we start, we're going to do up equals down. So first we do the bit where it's not moving, so where acceleration is 0. So up equals down, so R plus 40 sine alpha equals 20g. But sine alpha is 3/5. So R plus 3/5 times 40 equals 20g. And so R equals, let's stick that in my calculator, 20 times 9.8 minus 40 times 3/5. I'm not going to trust my mental arithmetic at the moment. 172. So that's 172 newtons. And then we're going to do F equals ma in the direction of acceleration. So going in the direction of acceleration, we've got this force. And going away from it, we've got this force. So F equals ma in the direction of acceleration. We're going to get 40 cos alpha minus 0.14 R equals m, which is 20, and a. Now we know cos alpha is 4/5, so 40 times 4/5 minus 0.14 times the R, which was 172, equals 20a. I stick that in my calculator, so I'm going to do 40 times 4/5 minus 0.14 times 172. And I'm going to divide that by 20. And I get 0.396 and its acceleration, so meters per second squared. So you're just resolving. Up equals down, so whichever way it's not moving, there's no acceleration, you can just go up equals down. And then in the direction of acceleration, you take those to be positive. Okay, so the crate is now pushed along the same floor using a handle. The handle is again inclined at alpha, and the thrust is still 40. Was it 40 before? Yeah, it was tension before because it was pulling away. Okay, so if we're going to push, what's going to change? Now, remember before, if you have a force going upwards, it means the two components are going along. So in order to go from here to here, I have to go along and up. Whereas if it's a thrust, I'm going to go down and along. So the along doesn't change, but now we're going down. And remember, R acts upwards. So now what that's going to do is going to make the R bigger, because R is going to equal 20g plus whatever this component is. So 40 sine alpha. You don't need to calculate it, but essentially you're going to say, well, R will be bigger, which means the friction will be bigger, which means there'll be less acceleration. So that's your explanation, will be pushing will make R larger, therefore friction larger, therefore acceleration will decrease. I can't spell decrease. All right, let's try again. Decrease. Okay. Right, next question. Right, question 4. Okay, we've got a package of weight 20 newtons. Okay, so it's already given you a weight. Don't add G to it. The amount of students that do that, and I want to give them the marks because I can see what they're doing, but you lose. Yeah, so you just want 20 there. It's already newtons. It's not a maths. Okay, and the minute you do that, you can do your resultant force, and before you do anything else, you can alpha, 20 sine alpha, 20 cos alpha. Okay. As inclined, you've got another force. Okay, package P is modeled and it's moving up, so we can do our acceleration up. So that means friction is acting down the plane in the opposite direction, and we're not given the coefficient, so we're just going to write mu r. We've also got this other 30 newtons that needs to be resolved. So in order to go from this end to this end of the arrow, we're going to go perpendicular and then parallel. We get a Z angle. So this is alpha in this case. So then we get 30 sine alpha and 30 cos alpha. So now we've got everything labeled. Once it's labeled, these questions should theoretically become really easy. And you've also done a whole load of work because you've done all the resolving by labeling it. Okay, tan alpha equals 5/12. They generally only use triangles that, well, you should know your Pythagorean triangles, but if you don't, you could work it out. Sine alpha, so tan is SOHCAHTOA, opposite over, I'm just going to move so you can see that. So opposite over adjacent, so that's going to be 5/13, and cos alpha is 12/13. Okay, now it's saying find the magnitude of the normal reaction. So it's not moving up and down, so we're going to do up, or perpendicular going upwards equals going downwards. So what have we got going that way? We've got R, and going against it, we've got 20 cos alpha plus 30 sine alpha. Now we know cos alpha is 12 over 13. So we get 20 times 12 over 13 plus 30 times 5 over 13. Let's plug that in our calculator, gives us 30 newtons. And then it says, find the range of possible values of mu. Now, the reason it's saying possible values is because we don't know what the acceleration is, but we know that there is an acceleration, which means the forces going up the plane have to be bigger than the forces going down the plane because it's moving upwards. So we know for a fact that 30 cos alpha, because it's the only thing going up the plane, must be bigger than or equal to this going down the plane and our mu r. So we're going to have 30 cos alpha is bigger than 20 sine alpha plus mu r, which will be 30 mu, plus our friction. Okay, so we know what cos alpha is and we know what sine alpha is. So we're going to get 30, let's rearrange that. So we get 30 mu is less than or equal to, so if we move, so we get 30 times by 12 over 13 minus 20 times 5 over 13. Plug that into my calculator, divide by 30, gives me mu must be less than or equal to 2/3. Then it tells us the horizontal force is now removed and P continues to go up the plane until it comes to a rest. P then slides down the plane. Given that mu is 1/3, find the acceleration as it slides down. Okay. So if I then get rid of, what have we got? All right. So if I'm trying to do this so you can see what I'm doing. All right, so in an exam, what I would probably do is just re-sketch it very, very quickly. You're just copying out what you have there. You've got R, you've got 20 cos alpha, 20 sine alpha. You know that it's still going, well, you don't know if it's going up or down, but you need to find your friction. So initially it keeps going up. So you know you've got mu r going that way. Right, so you know that your nu r is equal to 20 cos alpha because there's no force, that horizontal force is gone. So you'll get 20 times 12 over 13, which gives you 20 divided by 13 times 12. Okay, so you get 240 over 13. So mu r is 1/3 times 240 over 13, which gives you 80 over 13. So that's your new friction. Right, now we know that it's now going down the slope. Now, when it goes down the slope, that mu r here, because they want to know the acceleration as it goes down, is going to act up the slope. It always just, the friction will always act against the movement. So because we're talking about sliding down, we're going to consider the friction going upwards. The only thing going down the slope now is we've got 20 sine alpha minus our friction, which we worked out to be 80 over 13, equals ma. Now we don't know m, we know the weight, but remember weight equals mg. If the weight is 20, then the mass is 20 over g. So m is going to be 20 over g a. We know that sine alpha is 5 over 13. We rearrange this and we end up with a equals 0.754 meters per second squared. Okay, so I hope that makes sense. big bit here that was a bit confusing is making sure, because they gave you the weight, it was easier initially, but then you've got to change it back if you want to use the maths. Okay. Next question. Right. Pulleys. Okay, so pulleys are easy. They're usually worth quite a lot of marks, but they always follow the same process. And again, it's labeling. You get your labeling right, these questions become really easy. So let's have a look. We've got, wherever we see a mass, straight away, we're just going to do mg going down. Wherever the pulley is, we always have tension acting towards the pulley. So tension acting towards. It tells you the particles are released from rest and A moves up the plane. It's always going to move up the plane. If I dangle something out the window, it's going to fall down. So in terms of your A-level mechanics, you're always going to be going this way, unless something breaks, which we'll talk about in a bit. And even then, there's always a process for these. Okay, so we've got the acceleration. Now, the fact it's a pulley tells you the tension is the same and the acceleration is the same. So when it tells you that, it tells you the rope is light is T, ends in T, tells you the tension is the same. Inextensible tells you the accelerations are the same. Okay, so that's just a way to remember that. So once we've got our labeling, we're not quite done yet. So it's a smooth slope. We don't need to worry about any, so we don't need to really worry about our R because it's, there's no friction to worry about, but I guess for completeness sake, you could draw it in, and wherever we've got our slope, we have our normal 3g sine alpha, sine theta even, and 3g cos theta. We're not really going to need the cos theta bit in this question. Okay, so we're going to find the tension. So once we've labeled it, like we said, nice and easy, we're going to split it. And we're going to think about each bit individually. So let's take the motion of B first, because it's easier. So for motion of B, so you're going to do F equals ma for B. B is traveling downwards. So your downwards force is positive and the other bit is negative. So we're going to take in the direction of acceleration, we get 3g minus t, which is my force, my mass, which is 3, and then A. My motion of A, in the direction of acceleration, the force that I have is T. Against acceleration, I've got 3g sine theta, and that equals 3A. Now we're told sine theta is 2/7, so we plug that in. T minus, so we've got 2/7, so that's going to give us 6/7 G equals 3A. Now I would just plug those under the simultaneous bit in your calculator and you'll get your two values. So when you calculate that, you'll end up with T equals, you can just plug it straight into your calculator. If you go to menu equations, simultaneous equations, you can choose one to be X, one to be Y. So you get T equals 18.9 newtons, and the acceleration comes out to be 3.5 meters per second squared. So even though part A doesn't ask for the acceleration, you're more than likely going to need it. So we might as well write it down. So we've got A is 3.5, and that's 3.5. Okay. Now these sorts of questions are always a part B or C of a pulley question, typically, and they always follow the same process. Step one, so what it's saying, step one, you will always need to find out the V just before it hits the ground. And depending on what the question gives you, you will always be using either V equals U plus AT, if they give you a time, or V squared equals U squared plus 2AS. So the first step of any of the second part of pulley questions are always the same. So here, they're released from rest, and it takes 0.8 before it hits the ground, at which point it goes slack, like it goes wobbly and the tension disappears. But before that, we're going to find out the speed as it hits the ground. So because we're given a distance, we're going to use v squared equals u squared plus 2as. So what we're going to end up with is v squared. They always start from rest. You can check it, but it starts from rest. You've got 0 squared plus 2 times 3.5 times 0.8. So v squared is 5.6. Now, if you find v squared, leave it as v squared, because if you end up needing to find a distance later, you're probably going to square it anyway, right? So we've got v squared equals 5.6. Step 2, you find your new acceleration with no tension, and it's always going to be one of two things. If it's a straight up and down pulley and it goes slack, your new acceleration is just going to be minus g, because it's only gravity that's going to be acting on it as it, starts to come back up again. If it's on a slope, your new acceleration is always going to be g sine theta. Now, the reason is if I have a slope and I've got my pulley, I can't draw, and I've got mg here, doesn't matter what that mg is, I'm going to have mg sine theta acting down the slope. Remember, there's no tension anymore. The tension is gone, right? But I know it's continuing to move up. So there's still an acceleration, but it's going to be decelerating because it's getting slower. So in the direction of acceleration, I've got 0 forces. Against acceleration, I've got minus mg sine theta equals ma. The m's cancel, and you're left with your new acceleration or deceleration of minus g sine theta if it's on a slope. So in this case, we know sine theta is 2/7, so we get minus 2/7 g. And now we want to know when it comes to rest. So we're going to use v squared equals u squared plus 2as again, but this time our old v squared is our new u squared. So v squared equals u squared plus 2as. We know it's now going to come to rest. So 0 equals 5.6 plus 2 times minus 2/7 g, which is our a, s. We rearrange that for s and we get s is 1. So we want the distance from the point C. So if you think about what's happened here, we want to know how much it's moved. So it's already moved 0.8. So what's happened is, let's see if I use a different color. Sorry, this is very messy. So as this goes down 0.8, this moves up 0.8. Then it goes all squiggly, but it continues to move up as it gets slower and slower and slower. And we've just worked out it's continued to move up for another 1. So the total amount that it's moved up is 1 plus the 0.8, so it's 1.8 meters. I hope that makes sense. Look through it again, maybe listen through it a bit carefully, but that's how all of these questions work. Then it says state 2 limitations that could affect the reliability. The marks team usually says something sensible, but it could be things like the model doesn't take into account, assumes the size of the packages. It assumes, or the shape of the packages. The rope might not be inextensible. We may not be able to assume equal accelerations. Any assumptions that are automatically made. Okay. Oops. I think this is the last one. So we've got another pulleys question, but this is like letters as opposed to like numbers, which always feels more confusing, but it actually just treat it in exactly the same way. Okay, so we're going to start off doing exactly what we did before. I'm actually going to make this bigger so you can see because the labeling is the most important bit of it. So it's a show that for the tension. So as long as you can see that, we should be okay. Right, so we've got 3 mg. Wherever we've got a mass, we've got 2 mg. Towards the pulley, we've always got tension. Okay, wherever we've got anything on a surface, we get a reaction force. And anything on a slope, we do alpha, 2 mg sine alpha, 2 mg cos alpha. Okay, and now we read it a bit more. We find it's a rough plane, which means we're going to have friction, which is going to be mu r, but we're given mu as 2/3, so 2/3 r. And we know this is going up, so this must be going down. Okay, that's everything that we need. So now we're going to split it and think about each of the motions separately. So we'll do the easy one first, motion of B. So we're going to do F equals ma. In the direction of acceleration, we've got 3 mg. Against acceleration, we've got t, and that equals 3 ma. And then the motion of A. So the same thing, in the direction of acceleration, we've got t. Against it, we've got 2 mg sine alpha minus 2/3 r. But r, we can see up equals down. The only other force is 2 mg cos alpha, and that equals 2 ma. Okay, so let's clean those up. Oh, we've got tan, I didn't do that. Tan alpha equals 5/12. So sine alpha equals 5/13. Cos alpha equals 12/13. So we end up with, let's rearrange it. So we end up with 3t minus 5/13 times 2. So 10/13 mg minus 2/3 times 2 times 12/13. So minus 16/13 mg equals 2 ma. We want to eliminate A because we're trying to find T. So we can, it's however you want to do it, simultaneous equations, but it's not, we can't use our calculators. So what we're going to do is, let's just combine these, which gives us minus 2 mg equals 2 ma. Is solve them simultaneously. So you could multiply this one by 2, this one by 3. So that gives you 1 and 2. So 1 becomes 6 mg minus 2t equals 6 ma. And the second one becomes, wait, where have I done? Yeah, 3t minus 6 mg equals 6 ma. When I take them away from each other, I have made a mistake somewhere. So I've got 3 mg minus t equals 3 ma. T minus 2 mg sine alpha minus 2/3, have I calculated that wrong? 2/3 times 2 times 12/13. So minus 16/13 mg equals 2 ma. 10 plus 16 divided, so that's minus 2 mg. And if I take them away from each other, I end up with, not going to end up with 12/5, am I? So I'm going to have 6 mg. So I'm going to have minus 2. So if I do 2 take away 1, I'm going to get 3 minus minus 2, which gives me 5t, minus 6, minus 6, so that's going to give me minus 12 mg equals 6 ma, so that's 0. So 5t equals 12 mg. No, I had done it right. Okay, 12 mg over 5. Clearly it's towards the end of this paper. And we've proved what we needed to. So I hope that makes sense. I've done it all in terms of m and g. Okay, I'm going to have to clear this just to move it up. So we've shown that's the case. After B reaches the ground, A continues to move up until it comes to rest. Before reaching P, determine whether A will remain at rest. So again, this is nothing to do really, it's to do with friction. So if the friction is more than the force that's pulling it down, then it will remain at rest. So the force going down the slope was 2 mg sine alpha, which came out to be, sine alpha was 5/13. So that gave us 10/13 mg. So that's my force going down the slope. My friction was 16/13 mg. Now, 16, the friction, is bigger than the force going down the slope, therefore will not move. Suggest 2 refinements to make it more realistic. Generally, an inextensible string is not realistic. So we could say inextensible string. So we'd have to say an extensible string. And maybe we take into account, don't model the blocks as particles, take into account their shape or their spin. Maybe the weight of the string could be taken into account. Anything that you've assumed, again, you can do that with. Okay. Right, so I hope that's been useful. I'm going to keep going through these this evening. I'll probably take 5 minutes and then do the next one if you're watching live. But ask away, ask any questions. I've got a manic week this week, and then from next week I can start looking at the comments. I know it might be too late for those of you that have done assessments, but hopefully these will stay and be useful for anybody else as well.